Hi, we are the Automated Flood Modeling and Risk Assessment and Milwaukee River Communities Group.
My name's Willie.
My name's Kian Mia.
I'm Daisy.
And yeah, so basically, the motivation behind our project was sort of climate change is increasing the frequency and severity of floods. And so basically, we're basically trying to help communities understand that risk better, especially because a lot of insurance companies are sort of retreating from these communities because it's just not financially viable to like support them. So instead, we're trying to give them an avenue of understanding the risk.
And to do this, we are using a physics program called HECRAS, developed by the U.S. Army Corps of Engineers. And basically, we are using HECRAS to perform a series of Monte Carlo simulations to help with our analysis.
Yeah. So basically, our general workflow, as you can see in this diagram here, we start with a bunch of inputs that have like distribution or variability, sort of. So this can include stuff like inflow, which is the amount of water flowing in, precipitation, land cover, that sort of thing. And then we can put it into HEC-RAS, run it a bunch of times with all of these different like combinations of variables. And what we get out is this histogram that'll have like the probability of each water depth happening. So I want to talk a little bit about the data generation, how we did that. For land cover, which basically just describes, oh, is the land here like a forest? Is it a grassland? Is it developed or is it not? They each have an associated friction and infiltration value associated with each of these kinds of land covers, and we model these using a beta distribution where alpha and beta both equal 5. Since we know the maximum and minimum like range of that value and sort of where the middle is.
And moving on to our inflow values, we got that by sampling the past 50 years of the USGS discharge data in our chosen location. So, for example, if we chose Asheville, we would take an annual hydrograph for the past 50 years and take the four biggest peaks in those graphs. Then we would fit those into a beta distribution and from there, we would have a list of alpha and beta values, which we could get our inflow from. And for precipitation, we randomly sampled storm duration and recurrence from the NOAA Atlas 14 tables. And with those, we generated a few hydrographs and exported them into DSS for HECRAS.
After getting the data we wanted, we'll use the data generated from the HackREST and import it into a NetCDF as a spatial data with a parameter set we desire along with their coordinate system data. And then after storing it into NetCDF, we'll convert into a GeoTIFF file that can be converted into a REST layer and will also be applied on a base map.
Yeah, so basically what all of this ends up becoming is sort of an interactive map that like anyone can sort of click around. So this is an example of the Asheville area, as you can see here. This is the area that was modeled by HECRAS because you have to generate a model for a specific area. So that's the land that was covered. And as you can see here, as you click around, there's different depths associated with each area. The darkest blue area is like, as you can tell, a river. And while these areas might be okay with on average getting like only 0.25 of a foot of water, we'd consider these areas more high risk. The numbers here aren't precisely accurate because we're still working to refine the model, but it is a framework that future work can use to improve.
So all in all, what we have from our project that we've been working on for the past 10 weeks is a successful data generation process that gives us accurate results from HECRAS and allows us to be able to perform these Monte Carlo simulations and create our histograms for risk analysis.
In the future, we first want to try to interpret real-time precipitation forecasts into the expected inflow, as well as trying to use machine learning to refine the shapes. Also want to incorporate uncertainty quantification to better assess for risk streams and also calculate the expected damages. What I also want to do that is, although it's said in the title that it's applying right now in Milwaukee River, in the future, it's very likely that we can apply the workflow to simulate results from other geographic regions to evaluate the generalizability and performance.
Yeah, so thank you for watching, and we are the automated flood modeling and risk assessment in the Milwaukee River Communities Group.